Hi guys, welcome back to final review, modules 3 and 4. We are on number 9. It says write the equation of parabola in vertex form that contains the points 3, -4, and -2, and -14, and has the axis of symmetry of x equals 1. So notice for this equation, I need to know y, a, x, k, and h. So the vertex, oops, this is not supposed to, here's another typo, this should be h. This should be k. So from the axis of symmetry, we can figure out what our h is. Sorry, this should also be minus h. Alright, so from the axis of symmetry, we can figure out what our h is. And then we can use points to find out an x and a y, but what we don't know is a and k. So since there are two things that we don't know, we're going to have to come up with a system of equations with two unknowns and solve that, and that'll give us our a value and our k value. Before we just needed to know a, now we need to know a and k. So let's start with this point here, plugging it into this equation. This up here. My y is -4. I don't know a. X is 3 minus my h value, because this is axis of symmetry, goes through the vertex. It goes through the vertex at 1. So 3 minus 1 squared plus k, which we don't know. All right, now doing it for the second point here, my y value is -14. I still don't know a. My x value is -2 minus 1 squared, and we don't know k. If you're not one of my students, this is a cursive k here. You're going to see your professors write it like that in college, so I'm getting you warmed up to that idea. All right, so then here's our system of equations with two unknowns. I'm going to make it look a little prettier over here. So -4 is equal to 3 minus 1 would be 2 squared, which is 4a plus k. And then -14, -2 minus 1 is -3 squared, so 9a plus k. So I have a system of equations with two unknowns. I'm going to you can solve this, keep in mind, you're going to have a calculator, so you can solve this with matrices, but I'm just going to go ahead and change the signs on these, because I know if I have k minus k, it's going to knock it out. So changing the signs, it's going to make the 14 positive, the 9 negative, and then the k will become negative. So positive 14 minus 4 would be 10. -9 plus 4a would be -5a, and then the k minus k gets eliminated. So I used the elimination method, got rid of k, now I can figure out what a is by dividing by -5. 10 divided by -5, we know a is -2. All right, and now we're going to plug that in either into the first equation or the second equation, it doesn't matter. Since I didn't butcher this first equation, let's just plug it back in here. We now know that a is -2, and so we can solve this equation to figure out what k is. So this is -4, 4 times -2 is -8, plus k. I'll add 8 to both sides, and I get k is 8 minus 4, which is 4. So my equation, which is what they asked us to do, would be y is equal to a is -2, x minus h, which is 1, squared, plus k, which we found is 4. All right, let's do number 10, just like that one. All right, so using this point here first, y is 12 is equal to a, we don't know, x is -5, minus, my axis of symmetry is at -3, so h is -3. So minus a -3 would become +3 squared plus k. For my second equation, 36 is the y. We don't know a. This time I got 1 minus a -3 would be 1 plus 3 squared plus k. Making that look a little prettier. We've got 12 is equal to -5 plus 3 is -2 squared. -2 times -2 is 4a plus k. For the bottom one, we got 36 is equal to 1 plus 3 is 4 squared would be 16a plus k. Again, they're both plus k, so if I just change the sign on one of them. When I add them together, we'll get rid of one of them. So 12 minus 36 would be negative 24. 4 minus negative 16 is negative 12a. K minus k goes away. Dividing by negative 12, negative 24 divided by negative 12 is positive 2. Now that I know what a is, I'm going to go plug it back into either of these equations. I'm going to choose the top one. 4 times a, which we know is 2 now. So I get 12 is equal to 8 plus k. Subtracting 8, I get k is equal to 4. So writing the equation, y is equal to a, which is 2, x, sorry, they got this all backwards, x minus h, x minus a minus 3, so x plus 3 squared, plus 4, which is our k value. All right, let's see if we can do one more. All right, a toy rocket reaches a maximum height of 75 feet after 3 seconds. If the rocket is 11 feet off the ground, after 5 seconds, write a quadratic equation for this model. So here we go. I'm going to put it on the first quadrant here. I don't know where it's starting just yet. So, but we know after 3 seconds, it's at its maximum height of 75 feet. So these are going to be seconds. If you have time in it, time is always going to be on the x-axis. I say always, but almost always on the x-axis. But when you got these height problems, definitely. All right, so after 3 seconds, we're at 75 feet, and then it says if the rocket is 11 feet off the ground after 5 seconds, so let's call this 5 seconds. We're at 11 feet. Write a quadratic equation to model this situation. So this is actually just like one of these problems. Whoops, not those. Where are they? Here they go. One just like 7 or 8, where we know the vertex, we know another point, we gotta go find our A. So this time we know our K. What we need to find is A. So remember your vertex is your H and your K, the other point is your X and your Y. So my Y is 11, we don't know A, that's what we're trying to find. X is 5 minus H, which is 3, squared plus K is 75. Subtracting 75, I get 64, and then over here I got 5 minus 3 would be 2 squared would be 4a. Dividing by 4, I get a is equal to 16. I'm like, it should be negative because it's upside down. Negative 75 plus 11 is negative 64, which you've probably been screaming at me saying. So my equation is negative 16 times x minus 3 squared plus 75. All right, number 12, he says you can do this in your Inspire. So, Miss Prez's bakery showed increasing profits, and then her profits began to decrease. I don't have my Inspire pulled up, so let me stop the video here, and I will start part 3 of this module with the calculator pulled up so that I can model this for you.